Okay, so we've already talked about how to sketch the parent function, just y equals cosine theta with no transformations. But we want to make sure we know how to graph y equals a cosine theta plus k. Okay, so with vertical changes. Okay, so the angles are no different than they were before. Directly on the right end of the circle, that represents angle 0. 0 radians. We use radians for graphing. It actually works a lot better than degrees. Okay, all the way around would be 2 pi. Right, halfway around the circle is half of 2 pi, which is 1 pi or just pi. Okay, halfway from 0 to pi is pi over 2. Okay, and then directly at the bottom is 1, 2, 3 groups of pi over 2, so 3 pi over 2. Okay, so again, these represent the angles around the unit circle. And since we're graphing cosine, we know cosine refers to the x coordinate where the angle hits the unit circle. Okay, so above for the unit circle, we knew that this point was 1 unit to the right. So we said x equals 1. But this time there's no coordinate plane, right? So we can't call this point 1 because maybe it got shifted over, maybe it got translated. Okay, but what we do know is that this point is the biggest x value on the whole circle, right? It's the furthest right. So whatever that maximum x value is, it occurs right here. Okay, so we're going to refer to these two angles as both having the maximum x value for the entire graph. Okay, and again, hopefully that makes sense when you look at the circle. The furthest right, meaning the biggest x value, occurs right here. Okay, now pi over 2, that x value is right in the middle of the circle, right? Half are to the left, half are to the right. So we'll call pi over 2 the mid x, the middle x value. Okay, make your prediction about what we're going to label pi as. Again, how does this x value relate to the other x values on the circle? This point is the furthest left, meaning this is the smallest x value on the whole circle. Okay, so we'll call this the minimum x value. Okay, and then 3 pi over 2, again, make your prediction. How does this x value compare to the others? It's right in the middle. Half are to the left, meaning less. Half are to the right, meaning more. Okay, so 3 pi over 2 is in the middle of the x values. Okay, and then the way we calculate these values, what is the maximum x value? It's the exact same way that we did the sine values. Okay, so there's only 3 values we care about. Right, the maximum, the mid, and the minimum. Right, this mid is a repeat. Okay, so the mid value is always simply going to be k, which is the vertical shift, vertical translation. To get to the maximum, you start at that midline, but then you can add the absolute value of a, the coefficient of cosine. Okay, and then to get to the minimum, you can do k minus the absolute value of a. Okay, and so just to introduce some more vocabulary, the absolute value of a refers to the amplitude of the function. Okay, so you might know the word amplitude from outside math. Amplitude is sort of like how strong something is, how powerful. Okay, so here amplitude stands for the absolute value of A. Okay, and you'll see it makes sense, right? You'll see the higher the amplitude, kind of like the stronger the graph, because it'll go higher up and lower down. Okay, so to practice this, let's go and look at the new handout you picked up today, the 6.2. Okay, and let's jump to problem 4, because this is a cosine one. All right, so we're gonna graph y equals 3 cosine theta minus 1. Just a quick reminder, this is a no calculator unit, so we don't need a calculator for any of this. Okay, so first we can identify that A is 3. So the absolute value of A is also going to be 3, right? If A were negative 3, absolute value would turn into positive 3, but here it just stays the same. And over here at the end, K is negative 1. Okay, so you can do the angles first or the key y values first. I'm just going to do the 3 key y values. For the whole unit, there's always going to be 3 key y values per problem that you need to figure out. Okay, so we just discussed how to find them, right? Again, I just call them the max, the mid, and the min. Okay, so the mid y value is always just going to be k, which for this problem is negative 1. The max y value, k plus the absolute value of A. So for this problem, you're starting at negative 1 and you add 3 to it. So you can go as high as 2. And then the minimum from the midline of k, you can instead go downward by the amplitude. So from negative 1, you can go another 3 units down to go as low as negative 4. Okay, so let's go ahead and draw a coordinate plane. Just 2 axes crossing. Okay, and we only want to label these 3 y values. Okay, so we got positive 2, negative 1, and then negative 4. Okay, so I would not label the ones in between. It's just going to make it more cluttered. Only label the key y values. Okay, and then we can also go ahead and label what we call the midline of the graph. We saw last class that these two functions, sine and cosine graphs, they have like a line that cuts right through the middle of them. So we like to represent that with a dashed line. Okay, so a dashed line going through negative 1. Okay, so now we need to figure out the angles. When we graph trig functions, they're not x values, they're angles, right? So to help identify what angles we're going to use, we can sketch a little circle over here. Okay, so we're basically going to recreate what we just did on the brain worksheet, but we'll do it without copying, just so we can remember. Okay, so everything we've done so far, the first key angle starts on the right. That's 0 radians. All the way around is 2 pi. Halfway around is pi. Halfway through the first half is pi over 2. Halfway through the second half, so 3 around is 3 pi over 2. Okay, so let's go ahead and label those angles on the horizontal axis. Okay, angle 0, angle 2 pi, angle pi, pi over 2, 3 pi over 2. All right, so now that we've done that, now we decide for each of these angles, is the point at the maximum, is it on the midline, or is it at the minimum? Okay, so again, for a cosine function, we're looking at the x of each point, not the y. Okay, so angle 0, this point on the circle is the furthest right possible, so this will be up at the max. Okay, so on the graph, angle 0 is at the maximum, which we've already identified as positive 2. Okay, so 0, comma 2. Okay, the next key angle of pi over 2, its x value is right in the middle of the circle. Okay, so pi over 2 will be on the midline. Okay, so not on the x-axis, right? The midline is at -1. Okay, so pi over 2 comma -1. Okay. Continuing, angle pi, its point is the minimum x. It's the furthest left point on the whole circle, which means the smallest x value. So angle pi will be at the minimum value. Okay, so angle pi is at the minimum value of -4. Next key angle, 3 pi over 2, is back in the middle of the x values. Okay, so 3 pi over 2 is at the midline of -1. Okay, and then 2 pi, we already identified is at the maximum, which is positive 2. Okay, and when you connect these up, please make sure you use a curve, not straight lines. Okay, so introducing a little bit more vocabulary. If you look back at the instructions for this page, I asked you to graph at least 2 what are called periods. Okay, so a period is basically one cycle of the graph before it starts repeating. Okay, so let me go back and show you a graph from last class. Okay, so when we graph the first sine function, we see that it repeats, right? This is identical to this. Okay, so each of these sections is one period. Like from here to here is one period, because that repeats identically over here. Okay, so this would also be one period. And this one over here would also be one period. Okay, so right now, we only have one period of the graph, right? It hasn't started repeating yet. Like, yes, these points are the same, but this one's heading downward, this one's heading upward. Okay, so the graph hasn't repeated yet. So we need to extend the graph. We can either extend it forward or we can extend it backward. Either one works. Let's go forward. Okay, so to go forward, you would just add another cycle through the circle. Okay, and we know that a full circle is in radians 2 pi. Okay, so we can just add 2 pi to all of these angles. Okay, 2 pi, or let's start over here. Pi over 2 plus 2 pi, which is 4 pi over 2. That's going to be 5 pi over 2. Pi plus another 2 pi means it's coterminal with 3 pi. 3 pi over 2 plus 2 pi, which is 4 pi over 2. That is coterminal to 7 pi over 2. And 2 pi plus another 2 pi would be 4 pi. Okay, so let's add these angles onto the right end of our graph. Okay, and then for each of these new angles, let's figure out which y value they get. Okay, so we already have 2 pi's at the maximum. Next, we have 5 pi over 2 is on the midline. Okay, so 5 pi over 2 on the midline. 3 pi is at the minimum. Seven pi over 2 is on the midline. And 4 pi is at the maximum. Okay, so hopefully you can see that when we connect up this next set of points, it's identical to the first set, right? So this is one period, here's a second period. Okay, so remember when we draw the arrows, we sort of just bend the curve down the other way so that we show we understand that it doesn't go up forever. Okay, so this would be a completed graph of y equals 3 cosine theta minus 1. Okay, and so when I say labeling all key points on both axes, the key points are midline points, maximums, and minimums. Okay, so for example, this maximum right here, I can see its angle is 2 pi and its y value is 2. This minimum, I can see its angle is pi, its y value is -4. This midline point over here, I can see its angle is 7 pi over 2, its y value is -1. Okay, so what happens sometimes is students only like label, they do like this, they don't fully label. Okay, so that means that I can't tell what angle this midline point is, so that's not going to be a completed graph. Okay, so again, all minimums, maximums, and midline points need to be labeled. Okay, you don't need to label the point itself, you just label it on the axes. All right, so are there any questions about any part of this problem? Yeah. Probably not. I think on the homework I might have said it has to be on both sides of the axes, but no. I'll probably just any two touching periods. Yeah, any two in either direction would be fine. Okay, other questions? Okay, so those were only vertical changes. This is a vertical stretch is what we typically call it, and this is a vertical translation. But we also have horizontal changes. Okay, so that's what we're going to introduce today. Okay, so let's go ahead and look at the next page. Okay, so very, very complicated looking function here, right? Some of these we know how to deal with. Some are brand new for today. Okay, so the good news is we can start with what we already know, and then we'll introduce the other stuff later. Okay, so step one, identify the midline shift, which is going to be k. All right, well, k, if you want, you can write the general formula is a sine bracket b parentheses theta minus h, close parentheses, close bracket, plus k. Okay, so again, looks like a lot, but you've dealt with a, h, and k many times. The only one that we haven't really done is b. Everything else is going to be the same as you're used to. Okay, so just one step at a time. The k value for this problem is +7. Okay, so the midline shift is, since k is 7, so that means that the midline shift is what we typically call a vertical translation. For trigonometric graphs, we use the term midline shift instead. Okay, but if you think about it, if you shift the midline, you're just shifting it up or down. So it's still a vertical translation. Okay, we just use different terminology. Okay, so since the k value is 7, if I ask you what transformation took place, K is 7, but that's not a transformation. What I'm looking for is the midline shift is you translated 7 units up. Okay, so we could graph that right away, or we can do the next part first. So let's do step 2. Identify the amplitude, which is calculated by taking the absolute value of A. All right, so A is the coefficient of the trig function. So in this case, A is 3. Okay, so the absolute value of 3 is still 3. Okay, so what this number represents is how much to go upward from the midline to hit the maximum, or how much to go downward from the midline to hit the minimum. All right, so actually, let's go ahead and graph the midline first. Okay, so jump down to step 5. Okay, so now because I see that the K value is very positive, I'm going to leave more room at the top than the bottom. Okay, and just from step 1, the fact that the midline shift was 7 units upward, that tells me the new midline, right? Typically, the midline is at y equals 0. If it gets shifted 7 units up, now it's at y equals 7. Okay, so we'll go ahead and mark 7 as a y value. Again, you don't need to count up to 7, just jump to 7. Okay, and let's go ahead and draw in a dashed midline, a horizontal midline that goes through it. Okay, so from here, right, you could have many lines that have this as a midway point, right? You know, it could be shallow, it could be very steep. The way we know which one it is through the amplitude. Okay, so coming back up here to step 2. Again, the midline is always simply K. So for this problem, we already identified that it's 7. The maximum is K plus the amplitude. Okay, so for this problem, K is 7 plus the amplitude of 3 is 10. The minimum, K minus absolute value of A. All right, so we already have 7 marked, but let's also mark the y values of 10 and 4. Okay, so up to this step, everything has been basically a review of last class. Okay, here's where we're going to introduce the new aspects that we haven't covered yet. Okay, so what does H do? Okay, so if you look at the equation, right, you look at the spot of H is getting subtracted from the variable. And again, we use theta for angles, not x. Okay, so if you can remember back to when we had like a square root function like this, right, here this means that the starting point was at 4, 1, right? So this was a horizontal translation. Okay, so it's going to be the same idea here, but instead of a horizontal translation, we call it a phase shift. Okay, so again, for whatever reason, people around the world have agreed that we use different terminology for trig graphs compared to other graphs. Okay, so you should know that a phase shift just means a horizontal translation. Okay, so what is H for this problem? Looking back up here. This is the one that people typically get wrong because you have to recognize that the minus sign is part of the formula. So h is not -2 or negative pi over 2, right? The minus sign is already there. H is the thing after it. Okay, so h is positive pi over 2. Okay, so h is pi over 2. So in words, what transformation happened? Again, you don't say pi over 2. The action that happened was that we, okay, we'll just say you translate pi over 2 units. And you have to say in what direction. Obviously, it's different to go left and right. When h is positive, that means you translate right. Okay, so we don't really know what to do with that on the graph yet, so we'll come back to it. Okay, so again, we haven't done anything with the pi over 2 yet. We will shortly. But let's move on to step 4. Use b to calculate the period or period length. Okay, so again, if I quickly go back to the first worksheet, how long was the period for the basic sine function? It started at angle 0 and it went to 360 degrees. So 0 to 360 degrees is 2 pi. Okay, so the basic period was 2 pi. But when we have a b value, that can be changed. Okay, so please write down this formula. The period length of both sine and cosine is calculated with the expression 2 pi divided by b. All right, so for the basic sine function I showed you earlier, here the b value, when it was just sine of theta, it's invisible 1 theta, right? 1 times anything stays the same. So 2 pi over 1 is 2 pi. Okay, but for this problem, it's not. All right, so b for this problem is positive 2. Okay, so again, for this particular problem, since b is 2, we do 2 pi over 2, which gives us pi. Okay, so sort of like how we calculated the 3 key y values, we're now going to calculate the actually the 5 key angles. Okay, so the start of the period is easy, at least. The start of the period is simply h. Okay, so we said earlier that h is pi over 2. Okay, so now here's a very common mistake that we can hopefully avoid. This pi is not necessarily the ending angle, it's the length of the period. Okay, so because we're not starting at 0, this is not the ending point, right? It'd be like saying, oh, you stand at the 3-yard line on a football field and you walk for 10 yards. You don't end at 10, you end at 3 plus 10 is 13, right? Because you got to consider the starting point. Okay, so jumping down to the end of the period, the way you calculate the ending angle of the period is you take the starting angle h and you add to it the period length. Okay, so for this particular problem, you're starting at pi over 2, and then we've calculated, you go pi units past that. Okay, so you got to do pi over 2 plus pi. Pi is equivalent to 2 pi over 2. So pi over 2 plus 2 pi over 2 would be 3 pi over 2. Okay, so let's take a second and just catch up on our graph. So pi over 2 will go a little bit to the right of the origin. Okay, and then we want to jump to the end of the period, which is at 3 pi over 2. Okay, so 3 pi over 2 is 3 times pi over 2. So it should be 3 times as far away from the origin. Okay, and now just like I did when we were doing the circle, we're gonna cut this in half. Okay, so go ahead and mark halfway between these. Okay, so what is halfway between pi over 2 and 3 pi over 2? To find halfway between two things, you just find their average. Okay, so like if I ask you what's halfway between 6 and 8, of course the answer is 7. But the mathematical calculation is you add the two numbers together and divide by 2. Right, so to find halfway between any two things, you can find their average. Okay, so let's go ahead and find what's halfway between pi over 2 and 3 pi over 2. Okay, so this one's going to look kind of funny because you've got like fractions within fractions. But again, you add the angles together and divide the answer by 2. Okay, so up top, you've got 1 pi over 2 plus 3 pi over 2 is 4 pi over 2. And don't forget, you still have the big divide by 2. Well, the numerator simplifies. 4 pi over 2 is 2 pi. And now 2 pi over the bottom 2, 2 pi divided by 2 is 1 pi, or just pi. Okay, so halfway between them is pi. Okay, and we'll mark that on step 4 as well, right? So I refer to this as halfway through the period. Okay, so I'm just going to mark down that it's pi, angle pi. Okay, so we now need to split each of these halves in half as well. Okay, so let's start with here. Okay, so this point is halfway between pi over 2 and pi. Okay, so we could do what I did before. We could do this complicated fraction within a fraction thing, but there's a better way to approach it. Okay, so let's think back to the original problem, right? When I asked you what's halfway between pi over 2 and 3 pi over 2. Okay, well, we know that anything you can call a invisible coefficient of 1. Okay, so 1 pi over 2 and 3 pi over 2. Well, the pi over 2 part matches, right? So that part's just going to stay. So really, you only need to figure out what's halfway between 1 and 3. And of course, that answer is 2. And 2 pi over 2 reduces to pi. Right, so this is a much faster way of finding the halfway point, right? If you can make the denominators match, then you only need to work with the numerators. Okay, so let's try that strategy here. We're going to try to find halfway between pi over 2 and pi. Okay, so right now they don't have a common denominator. So I'm just going to write it below. I'm going to rename pi over 2 as 1 pi over 2. And pi, I can call 2 pi over 2. Okay, so the pi over 2 part matches, but the problem is halfway between 1 and 2 is 1.5. We don't like to mix fractions and decimals. Okay, so when it doesn't work out nicely to a whole number, what you can do is multiply both numerator and denominator by 2 over 2. Okay, so 1 pi over 2 is equivalent to 2 pi over 4, right? If you just double both top and bottom. And same thing over here. If you double both top and bottom, you get 4 pi over 4. Okay, so now it's a lot easier, right? Because the pi over 4 part matches, so you keep it. And you only need to figure out what's halfway between 2 and 4, which is 3. Okay, so the angle that's halfway between pi over 2 and pi is going to be 3 pi over 4. Okay, so again, the strategy, I got them to have a common denominator. And then once I did that, I only need to focus on the coefficient of the numerator. Okay, so again, I ignore the pi over 2. I just focus on the numerator, 1 and 2. Because those halfway between them is a decimal, I doubled all the numbers to spread them out. And then I could more easily find the halfway number. Okay, so the angle 1/4 of the way through is 3 pi over 4. Okay, so let's have you guys try it out. See if you can find the angle that's exactly halfway between pi and 3 pi over 2. Okay, so hopefully you can copy the strategy that I showed you for the first one. Okay, so to find halfway between pi and 3 pi over 2, we would need to come up with a common denominator first. So, 1 second, sorry. Okay, so 3 pi over 2 and pi, right? We already know pi can convert to 2 pi over 2. But if you compare pi over 2, 2 pi over 2 and 3 pi over 2, right? Halfway between 2 and 3 is 2.5. Okay, so we bump it up a little more. If we double both of these, we get to 6 pi over 4. Okay, and now we can more easily compare, okay, the pi over 4s match. So just halfway between 4 and 6 is 5. And don't forget to keep the pi over 4. Okay, so that would be the last key angle for this period. Okay, so you notice we now have 5 angles and 3 y values marked. Okay, so that's always what you need. You always need 5 angles per period and 3 y values. Okay, so now we're ready to sketch the graph using the pattern as we go around the circle. Okay, so this is going to be our galaxy brain understanding of the sine function. Okay, so why don't we go back here? Okay, so back on the front side. Okay, so the most advanced version of the of the sine function. Okay, so this is every possible transformation. You can have an A, a B, an H, and a K. Okay, so how this differs from the previous one is that, sorry, let's go a little bit one step at a time. Go ahead and mark the 4 usual points, but don't label them yet. Okay, so up till this point, we always called that rightmost angle angle 0, right? Makes sense, you start at 0. But when there's an h value, that starting value gets shifted. Okay, so that first point is not going to be 0, it's going to be h. Okay, and I'll just clarify this is the start of the period. Okay, and then going all the way around, again, we used to call it 2 pi because we started at 0 and the period length was 2 pi, so we always ended at 2 pi. Okay, but now the end of the period is affected both by h and by b. Okay, so I'll call all the way around as h plus period length. Okay, if you really want, you can say h plus 2 pi over b, right? Because period length is 2 pi over b. But I think when you get too many formulas, it gets easy to mix them up. Okay, so those are really the key ones. And then after that, you just cut it in half. And then you cut the first half in half. And then you cut the second half in half. Okay, so I'm not going to bother to label the others. But what we see here is that whatever angle the start of the period is, whether it's been shifted by an h or not, for sine, it's still in the middle of the y values. Okay, so on the other side, we were talking about cosine, so we were looking at the x values. But for sine, we're looking at the y values. Okay, so no matter how your sine function has been shifted, if it's been moved up or down or stretched out, the start of your sine graph will always be on the midline. Okay, so let's now do the actual graph back on this paper. Okay, so we can go ahead and draw a little circle to reference. Okay, I'm not even going to bother to label the angles though. I'm just going to label the y's. Okay, so sorry, let me get rid of some of this so it's not too crowded. Okay, so the first key angle of our circle, because we're doing sine, we need to know its y value. Okay, but we're just going to describe it in terms of minimum, maximum, or midline. Okay, so this first key angle is on the midline. It's in the middle of the y values. Okay, so what that means for our graph is the first key angle on the axis, which was pi over 2, that's going to be on the midline. Okay, so first key angle, pi over 2, go and put a dot on the midline. Okay, the next key angle is going to be 3 pi over 4. Okay, and from the circle, we can see that this point is the highest point on the whole circle. So this is going to be the maximum y. Okay, so again, that second key angle is going to be at the maximum y. Okay, so 3 pi over 4 is up at 10. Okay, continue around the circle. The third key angle on the circle right here. This is back in the middle of the y values, half above, half below. Okay, so that third angle is back on the midline. Okay, move on to the fourth angle. Fourth angle is at the bottom of the circle. It's the lowest point possible, so this will be the minimum y. Okay, so that fourth angle of 5 pi over 4 is going to be at the minimum y value of 4. Okay, and then all the way around, right? So the fifth angle overlaps with the first angle. The fifth angle is back in the middle of the y values. So that fifth angle is back on the midline. Okay, so hopefully you see the shape of the graph is the same, right? But obviously the numbers are different. Okay, so there's one period of the graph. So before we continue, are there questions on where these came from? Okay, so I asked you to do 2 periods, or I will be asking you to do 2 periods. Oh yeah. So it seems like, oh wow, we got to do double the work, but actually it's very fast from here. Okay, especially if you use my strategy for finding the halfway through the angles, right? So look at these angles down here, the ones that I have in purple: 2 pi/4, 3 pi/4, 4 pi/4, 5 pi/4, 6 pi/4. So yeah, some of them are not reduced, right? Up here are the reduced versions, but it's actually easier to continue the pattern with the unreduced forms, with the common denominators, right? So if you want to continue forward with another period, you just keep counting the same way, right? So after 6 pi/4, the next angle would be 7 pi/4. Okay, after that would be 8 pi/4. Okay, and I'm not even going to make you reduce it. If you want to leave it as 8 pi/4, that's fine. Okay, then 9 pi/4, then 10 pi/4. And again, yes, if you want to reduce any of these, you can, but it's actually easier to see the pattern when you don't reduce. Okay, and then hopefully you know by now that the pattern is going to repeat. Okay, so the first point of the period is on the midline. We already have that. The next point is up at the maximum. Okay, so after the midline point, you go up to the maximum. The point after that is going to be back on the midline. After that, you go down to the minimum. And lastly, you end back on the midline. Okay, so again, you can see that that second period took like 15 seconds because you just increase the numerators by 1, and then you draw the same shape you had the first time. Okay, so this would be a completed graph. Okay, so you can see every midline point, I can see the angle and the y value. Every maximum, I can see the angle and the y value. Every minimum, I can see the angle and the y value. Okay, so that's what I'm looking for you to label, right? You don't have to label the individual points, just have them labeled on the axes. Okay, so questions on any of this? All right, so let's give everyone the chance to try to put it all together then. Okay, so this next one over here, notice, is cosine. Okay, so here we were doing sine, so it was all the y values, right? This one is cosine. Okay, but everything else is the same, right? The only difference is when you get to step 5, right? Instead of starting at mid y, you'd start at the max, right? But steps 1 through 4 are identical for both sine and cosine. Okay, so go ahead and get started. I'll check in periodically to make sure you don't get too far off track. Okay, so for this problem, A is invisible 1. I already talked about B is a half. H is the opposite of what it looks like because it's minus negative 3 pi/2. And K is what it looks like. It's negative 3. Okay, so the midline shift, well, K is -3. So the midline is -3. The action is you translate 3 units down. Okay, but again, the actual midline is going to be y equals -3. Okay, the three key y values, midline is K, maximum K plus the absolute value of A, which is invisible 1. Minimum from -3, you can go 1 unit downward to go as low as -4. All right, so the three key y values are -4, -3, and -2. And I'll go and draw the dashed midline as well. Okay, I already mentioned how the h value is -3 pi over 2, right? So that's going to be our starting angle of the period. Okay, and I already calculated the period length. Since b is a half, 2 pi divided by half equals 4. Okay, so to find the end of the period, I do h plus the period length. Okay, so I started at -3 pi over 2, and then I add 4 pi to that. 4 pi or 4 pi over 1 is equivalent to 8 pi over 2. So -3 pi over 2 plus 8 pi over 2 is 5 pi over 2. Okay, so positive 5 pi over 2, I'll jump over to the other side. Okay, so what's halfway between those? Notice the pi over 2 part matches, so I just need to worry about the -3 and the 5. Okay, so halfway between -3 and 5 is 1. So 1 pi over 2, or just pi over 2. Okay, halfway between these already have a common denominator, so I don't need to double anything. Just what's halfway between -3 and 1? -1, so -pi over 2. And then what's halfway between +1 and +5? That's going to be +3. Okay, so these are my 5 key angles: -3 pi over 2, -pi over 2, pi over 2, 3 pi over 2, 5 pi over 2. Okay, and then now I can use a circle to know which point goes where. Remember, this is cosine, so we want the x. The starting angle is furthest right, so that's at the maximum. Okay, so the starting angle is at the maximum. The second angle is in the middle of the x values. So second angle is on the midline. Okay, so now notice for this problem, 0 is not a key angle. So we skip right over 0. A lot of times students make a mistake. They assume 0 has a point because it often does, but this time it doesn't. Okay, so the third angle skips over to pi over 2. The third angle is furthest left, so it's at the minimum. Fourth angle back in the middle, on the midline, I mean. And fifth angle back up at the maximum. Okay, so here's my first period. Okay, and then for a second period, I just look at the pattern: -3 pi over 2, -1 pi over 2, 1 pi over 2, 3 pi over 2, 5 pi over 2. So this time the numerator is increasing by 2. Okay, so next up would be 7 pi over 2, oh, wrong color. 7 pi over 2, 9 pi over 2, 11 pi over 2, 13 pi over 2. Okay, and again, the pattern, you don't even need to look at the circle anymore. Start at the top. Next point's on the midline. next point's at the minimum, back to the midline, back to the maximum. Okay, some of you might have gone backwards. That's also very easy because you just subtract 2 every time, right? 5 minus 2 is 3, minus 2 is 1, minus 2 is -1. Okay, so on this side, it'd be -5 pi over 2, -7 pi over 2, -9 pi over 2, -11 pi over 2. And again, the pattern is the same, right? Start at the top, down to the midline, down to the minimum, back to the midline, back to the top. Okay, so I did 3 periods. Again, you only have to do 2, but I just didn't know if you were going to go backwards or forwards, so I just did both. Okay, so, as you get used to this and you begin seeing these patterns, like how the angles, you can, just count forward. You don't have to manually calculate. Just like everything, it comes easier with practice. Okay, so if it seems very overwhelming right now, that's natural. But, if you just keep at it, keep practicing, you'll begin to notice the patterns and they'll become a lot easier. Okay, so let's jump over to the last page. Okay, we can also go backwards. We can look at a completed graph and come up with the equation of it. Okay, so one thing that we need to understand here is that sine and cosine are just, well, let me not spoil it. 1 second. Okay, so here, let me see if I can get to radians. Okay, so let me switch my screen too, so I can. Okay, so if you look up here, please. So in red, I've got the sine function, right? We know that sine starts on the midline, then it goes up, then it goes down, then below, and so on. On the other hand, cosine, the angle 0 is at the very right. So it starts at the top, the maximum, then it goes down, then to the negatives. Okay, so when we overlay these two graphs, we see they're not the same, but they're shifted, right? So if you just do a horizontal translation, or either way, right, eventually they will match up. Okay, and they can actually match up in different ways, right? You can go a little bit to the right, you can go really far to the right. So there's actually infinite ways to write an equation for any specific graph because the graph repeats, right? So you can shift over 1 loop or 2 loops or 3 loops. Okay, so with that in mind, we're going to try to obviously do it as simply as possible. Okay, so going back to the problems on your paper. Here, I asked you to use cosine as your parent function. Oh, sorry, you can't see that. Okay, so I asked you to use cosine for these top two. Okay, so the general formula, remember, is y equals a cosine bracket b parentheses theta minus h, close parentheses, close bracket, plus k. Again, looks like a lot, but you've done a, h, and k before, and theta is just the angle version of x. So again, the only new thing is b. Okay, so you can start in various ways. I typically start by identifying k. All right, so k, the midline shift, we can identify the midline by looking at the what is halfway between the maximum and minimum. Okay, so you can just do this visually, right? I'm sure you guys can see where the line is that goes halfway through. Okay, so again, I'll label this step 1. Okay, so step 1, identify the K value. Okay, the midline is right here. This grid's a little tricky. Notice each box is not worth 1 whole. Down here is -3. So that means that every 4 boxes is worth 1. So this is -1, this is -2. Okay, so the first thing is identify that K is going to be -2. Right, whatever the midline is, that's the K value. Okay, from there, I would probably do the A value next. You don't have to, but that's just what I like to do. So remember, the A value is related to the amplitude, which tells you how tall or short the graph is, basically, or more formally, the distance from the midline to the maximum. Okay, if I go back real briefly, right? So in this problem, the distance from the midline to the maximum from 7 to 10 is 3. And if you look back at the equation, A was 3. Okay, so what is it over here? The midline is at -2. The maximum is at -1.5. Okay, so A is going to be 0.5 or 1/2, right? Because it's only half a unit up. Okay, so that's the second thing I did. Okay, third, you can do either B or H next. Let's do B. Okay, so what did B control again? B has an impact on the period length. Okay, so looking at this graph, remember a period is 1 cycle of the graph before it starts repeating. Okay, so here is 1 cycle. And then here would be the second identical cycle. Okay, so each of those is 1 period. You can use either this one or that one. I would probably choose the one with the positive numbers. Okay, so this is 1 period. So to find the length, you just take the ending angle minus the starting angle. Okay, so this period ends at 2 pi. It started at 0. Okay, so 2 pi minus 0 is 2 pi. Okay, this is something that leads to a lot of mistakes. A lot of times students just take the ending angle as the period length. Yes, for this problem, it's the same because you started at 0, but if you started at anything else, it wouldn't be true. Okay, so again, ending angle minus starting angle to find the period length. Okay, so that's 2 pi, but B is not 2 pi. Okay, what is B? Here we need to remember the formula that the period length is 2 pi divided by B. Okay, so normally I tell you B and you calculate the period length, but this time I told you the period length and I'm asking you for B. Okay, so you substitute the 2 pi for the period length. Okay, so maybe you can already tell what B is, but if not, you can always just solve the equation. To get rid of a denominator, multiply both sides by it. And then divide both sides by 2 pi. So B equals 2 pi divided by 2 pi, which is 1. Okay, so B ends up being invisible 1 for this problem. I'll write it temporarily, but it's going to go away, right? Because the B multiplies 1 times anything stays the same. Okay, and then lastly, H. So remember, H is the horizontal translation, which we call the phase shift for trig functions. Okay, so how do you identify H? So to identify H, you have to remember what normally happens at angle 0, and you need to see where does it happen here. Okay, so that probably made no sense, so let's draw a picture. Okay, so normally at angle 0 for cosine, right? Cosine is x, so this is the max. Okay, so the parent cosine function, the basic cosine function, has a maximum at angle 0. Okay, so H would shift that. H would shift the maximum from 0 to somewhere else. Okay, so if we look at this, at angle 0, there is a maximum. So we can say that, oh, the maximum didn't get shifted at all, right? So we could say that H is 0. Okay, but just to make things confusing, you also could say, well, actually, this is not the original max, right? You could say, oh, the original max got shifted over here, right? This was really the original point. Or you could say, oh, it got shifted this way instead. Because the graph repeats, there's an infinite number of ways you could do it. Okay, but again, we're just going to keep it simple. We're going to say that because there is a maximum at angle 0, H is 0. Okay, so we can simplify this quite a bit. 1 times anything stays the same, but also theta minus 0, anything minus 0 stays the same also. Okay, you do still have the minus 2 at the end. Okay, so last thing we'll do is try to come up with an equation for this one. Okay, so go and take a minute or two and see if you can find an equation. Okay, so again, there's infinite ways to do this. So you may come up with a different equation than your neighbor, and you both might be right. Okay, but go and give it a try. Okay, so the midline here is positive 1. So k is positive 1, so you'll have a plus 1 at the end. The amplitude from 1, you can go as high as 3. So a is 3. Oh, so no. From 1 to 3, you only go up 2. Okay, so a is 2. The b value, well, the period length is 2 pi. 2 pi minus 0. Okay, so it's the same calculation we did earlier, right? So b is 1. Okay, so I'm not going to write that. Okay, now what about h? So normally cosine has a maximum at 0, but you can see here, it either got shifted to the right to pi or left to negative pi. We're not sure which one. It could be either. Okay, so either of these would be correct. Okay, because again, you don't know if you shifted right or if you shifted left. Okay, and there's actually other ways to do this also, but we'll save those.